One of the first things that you need to know about chiral molecules is that there is a chiral center present. For your course, you should only focus on the carbon, which is chiral. So there are three requirements that we have to fulfill for a chiral carbon. The first is it must be sp3 hybridized. The carbon should have 4 electron densities around it. It cannot be sp2, it cannot be sp. The second requirement that has to be fulfilled is that all of these 4 electron densities or groups around the carbon have to be different. And within that structure, there should not be any internal symmetry or plane present. For example, let's look at this carbon. And remember that a carbon always have a tetrahedral geometry. In this particular set, this bond, which is coming out, and this bond, which is going at the back, both of these bonds are in the same plane, while these bonds, these two bonds are in the same plane to each other. There are 4 groups around this carbon. So the first requirement of being sp3 hybridized is fulfilled. The second requirement, all 4 groups have to be different. So there is a methyl group here, a hydrogen group here, a hydroxy group here, and an ethyl group right here. So this carbon is fulfilling both of these requirements. And it is also fulfilling the requirement of absence of any symmetry. And hence, we label this carbon as chiral carbon. The next thing that we need to learn is at the chiral carbon, what is the configuration? Is it R or is it S? R and S always exist in pairs, but we need to know how do we define our chiral carbon as R enantiomer or the S enantiomer. First, you have to make sure that the carbon that you want to label as R or S is indeed a chiral carbon. The second thing that we do is we prioritize the 4 different groups based on their atomic number. Whichever is the atom which is directly attached to them, and then we keep moving away from the carbon of our interest. Then we compare atoms A, B, and so on. We always assign the smallest group as number 4. For our structures, double bonds and triple bonds, as well as branched chains will get priority. Your number 4 group or the smallest group should always be at the back. This would help you hold the group down and then see if your groups are moving from number 1, 2, 3 in a clockwise manner, or are your biggest groups moving from 1, 2, 3 in an anti-clockwise manner. Clockwise means R, anti-clockwise means S has to be labeled here. Coming back to our original structure, Let us first assign the R or S at this structure. So if you notice, there are several carbons on this structure, but which carbon is going to be our carbon of interest or the chiral carbon that we have to work around? And we observe that this carbon is the only chiral carbon. And this is the only carbon that we can label as R or S. So our first requirement is fulfilled. There is a chiral carbon and we are going to look around that carbon. We are now going to assign priority. The smallest group gets the priority of number 4. So how do we look at that? From the chiral carbon, you look at the first atom attached. Look at your periodic table and decide who has the highest atomic mass. And we see hydrogen has the smallest atomic mass, and we label this group as number 1. Oxygen has the highest atomic mass, so we label this group as number 1. The competition is between the methyl and the ethyl group. Rewriting my structure here, I see that I can describe my methyl group and ethyl group in this particular fashion. So let's say that these were my first atoms which I was looking at. My atom A. I can decide from these atoms, but I cannot decide among these atoms. For this, I will have to look at the atom next to my chiral center. So remember, this is my chiral center. This is the first atom which is attached to my chiral center. These are the next second atoms that are attached to my chiral center. In the same manner, to this atom, this is the second atom attached to this chiral carbon. This is also a second atom attached to my chiral atom. And this is also my second atom attached to my chiral atom. On this side, hence, since I cannot decide upon just carbons, I decide on this very carbon A, there are 3 hydrogens. Whereas on this group, for this carbon A, there are 2 hydrogens and 1 carbon. So if you compete between these 2 B atoms, 2 of these hydrogens can cancel out with each other. What is left is 1 hydrogen and 1 carbon. So the carbon, because of its higher atomic mass, will take more precedence. And hence, if you compare these 2 groups, this particular group will get more priority. So we have already assigned number 1. This group will be number 2. This group will be number 3. So looking back, we see that we have fulfilled our first requirement, whether the chiral carbon or the carbon of our interest is chiral. We have also prioritized the 4 different groups based on their atomic number. And we have assigned the smallest group as number 4. I want you to remember this. Your number 4, the third step is that your number 4 or the smallest group should be at the back. Once you have confirmed that it is at the back, you will then look at if your molecule moves clockwise or if your molecule moves anti-clockwise. And we are going to see here. Let's just say I have this molecule and I want to rewrite it in the same orientation. I keep the dashed bond at the back. I keep the wedge in the front. And instead of writing all of these groups, I can just write it as 1, 4, 3, and 2. At this point, I want to see that where is my number 4? And I see that my number 4 is indeed at the back. Let's say I have these two bonds, the red bond and the black bond, both of them in the same plane. I also have these two other bonds which are also in the same plane. I'm going to insert my bonds so I can create my tetrahedral shape. Let's say that this red pencil at the back is number 4. I can hold on my red pencil and I can then look at only the first 3 bonds that I have.